Now, something we've done in the past. In the past, I've asked you to find the exact value of certain trig functions, like, for example, cosine of 30 degrees, or a sine of 7 pi over 6, or tangent of negative 45 degrees, or whatever it happens to be. Now, when I say find the exact value, what are you going to do? I already gave you a big hint. Yeah, look it up on the unit circle, okay? I can type in cosine of 30 in my calculator. It's going to tell me 0.8660 something, something, something. But that's not an exact value, is it? That's a rounded number. Eventually, we have to round that off. And so we don't want to round. We want to have exact values. We stay more accurate with what we're doing. So we can look up cosine of 30 degrees right on a unit circle. And what's it tell you? Or maybe you have it memorized. That would be good too. Yeah, if I go right here, 30 degrees is there. Cosine is square root of 3 over 2. And that's our exact value. How about sine of 7 pi over 6? Yep, sine of 7 pi over 6. What do we get on there, Olivia? Oh, right here. So 7 pi over 6 is there. Which one's going to be the sine value? There we go. I know you're back there. It's going to be negative 1/2. And so it's our y value. Cosine is the x, sine is the y value. This gives us negative 1/2. And tangent of negative 45, we added some tangent values on there. And so tangent of negative 45, well, positive 45 is up here, which means negative 45 is down here, and the tangent would be negative 1, wouldn't it? So we have that. And we were able to do that. Now, we only had certain angles on the unit circle. Those are the angles we used a lot. 30, 45, 60, those multiples, and away we go. But what if we wanted some other angles? What if we wanted to do, for example, I don't know. What do you think? What if we did cosine of 105 degrees? Or the sine of 15 degrees? Now those aren't on the unit circle, but we still want exact values, don't we? We still don't want to be off. We don't want to have any error. We want to be able to be exact if we can. And so can we come up with some exact values of those types of things? And the answer is yes. And to do that, what we need are a couple other identities. And those identities are our sum and difference identities. And these are on page 886 in your book. Or they're up here if you want to copy them down. But we're going to want to get these into our notes. Okay? And so we have our sum identities, meaning the sine of a plus b, that's a sum, is equal to sine a cosine b plus cosine a sine b. We have one for cosine and tangent also. Cosine of a plus b is cosine a cosine b minus sine a sine b. Tangent's always that wild card in the group. Tangent of a plus b is tangent of a plus tangent of b, all over 1 minus tangent of a tangent of b. And the difference identities would be a minus b. The only difference between the sum identities and the different identities is we flip-flop the signs all the way through. Okay? So take a minute, copy those down, and then we'll show you how we can use them. Now, as far as these identities go, they're all about similar. You're just going to eventually, and you'll see this in a second, we're going to plug values in from our unit circle because we still want exact values when we're doing this. is we're going to plug values in from our unit circle, and then we just have to calculate out what it is and simplify it basically. Now the sine and cosine ones aren't so bad. Simplifying those is almost nothing, second nature, right? Tangent one gets to be a little more difficult because there we're dividing, which is not necessarily the easiest thing in the world to do with that. You know, you got fractions and you got addition with fractions and you're dividing, and that makes it a little more difficult, but we can still do it. It just takes a little longer to simplify it, that's all. But otherwise, it's just a matter of looking up what's my angle A, what's my angle B, and then plugging it into the formula and finding those exact values and simplifying. All right, so maybe you're still right, so I'll give you a minute again. Okay, so let's say we wanted to do, just like I had up there before, the cosine of 105 degrees. Now, if we want the exact value, again, I can type this out on my calculator. I go cosine of 105, and it's going to tell me it's negative 0.258819, but I have to round that off, and it's not an exact answer. So what we want to do is we want to find that exact answer. So what we need to do is we need to think of 105 as either the sum or the difference between two angles on our unit circle. Okay? If we want 105 degrees, think of two angles here. What can I do to get it? I could go 90 plus something, but I don't know 15. How about 60 and 45? 60 plus 45 is 105, isn't it? So let's do that. Okay? It's not the only way to get there. There's other ways to get 105, but well, let's take it that way. So let's go cosine of 105. It's the same as the cosine of 60 plus 45. Now, when you think about that angle addition, this is a sum, isn't it? And so now we look at our identities and we're looking for a sum for the cosine. And so for cosine, cosine of A plus B is equal to cosine A cosine B minus sine A sine B. Cosine A cosine B minus sine A sine B.
Where'd you get the 60 and 45?
Because 60 plus 45 is 105. We just needed two angles on our unit circle to get there.
Oh, so
You know, and that just ended up being the, I thought, the easiest way to get there. Could have done 135 minus 30. That could have done, you know, there's other ways of getting there, but 60 and 45 seemed a nice, easy way of getting there. All right, so now when I take a look here, my angle A is 60 degrees, so everywhere I see A, I'm going to put 60. My angle B is 45 degrees, so everywhere I see B, I'm going to put 45. So my cosine of 60 plus 45 is going to equal to, well, A is 60, so cosine of 60 times B is 45, cosine of 45, minus sine of A, well, A again is 60, times sine of B, and B is 45. You start out by just plugging the numbers in. And then from here, we just look them up on our chart. So, what's the cosine of 60 degrees? Didn't we just have that up there? Oh, no, we didn't. Cosine of 60 is a half. That was sine. So, cosine of 60 is a half. So this right here is 1/2 times cosine of 45. Here's 45, cosine of square root of 2 over 2. Minus sine of 60. Well, the sine of 60 is square root of 3 over 2 because the sine is my y value. Times the sine of 45, square root of 2 over 2. Well, now I just have to multiply fractions. And how do I multiply fractions? Top times top, bottom times bottom. 1 times square root of 2 is square root of 2. 2 times 2 is 4, minus square root of 3 times the square root of 2 is the square root of 6 over 2 times 2 is 4. They have a common denominator already, so we can combine them and say this is square root of 2 minus square root of 6 over 4. And that is the exact value for the cosine of 105. If you have a Casio, it'll actually give that to you. Looks a little different, doesn't it? But it's the same thing. Instead of positive square root of 2 minus square root of 6, this one has negative square root of 6 plus square root of 2. But it's the same thing, right? It just depends on what you use for your A and what you use for your B in terms of what's where. That's all. Okay? But there's our exact value for cosine of 105. How about the sine of 15 degrees? That was the other one I had up there before. How can I get 15 degrees based on two angles uncircled? 45 minus 30. So we can think of this as sine of 45 minus 30. Well, sine of 45 minus 30, that's a subtraction one now. And it's for the sine function. So I look at subtraction for the sine function. Well, subtraction for the sine function is right here. Sine of A minus B is sine of A times cosine B minus cosine A times sine B. So that's the identity we're going to use. So if I do the sine of 45 minus 30, which is 15, that's what we're looking for, is 15. A is 45, so I put that in everywhere I see A. B is 30, so I put that everywhere I see B. So that is sine of A, that's 45, times cosine of B, that's 30, minus cosine of A is 45, times sine of B, which is 30. Now we start looking things up. Sine of 45, we did that one up there, but what is it? Square root of 2 over 2, right off the unit circle. Cosine of 30, square root of 3 over 2, minus cosine of 45, square root of 2 over 2, times the sine of 30, is 1/2. Square root of 2 times square root of 3, that's square root of 6. 2 times 2 is 4. Minus square root of 2 times 1 is square root of 2. 2 times 2 is 4. And we have a common denominator, so we can put it up. Square root of 6 minus square root of 2 over 4. Now notice it's very, very close to the one above, isn't it? It's very similar. Well, you're working with all the same numbers on the unit circle. Your unit circle only has 1/2 square root of 3 over 2, square root of 2 over 2, or maybe 1 or 0. So if you're working with all the same numbers here, you're going to get something very similar. This is positive square root of 2, that's negative, so it's a little bit different, but still very similar. Yes?
You can subtract the square roots.
No, because this is like an x and a y. You know, and you can't combine them together. You can, if they're common, like if you had 3 square root of 2 and 5 square root of 2, you could say that's 7 square root of 2, but you can't combine the square roots when they're different like that.
How'd you get it to show up on your calculator?
But you're not doing it?
No.
Oh, let me look later. I don't know if that one will do it or if it's just a color one here. All right, and then there's tangent, and tangent's always interesting. Isn't it? Always tangent screws things up for us, doesn't it? So let's say I want to do, for example, tangent of, let's go 15 degrees. Now how can I get to 15 based on what we have? I can do 45 minus 30, that's 15. I can do 60 minus 45, that's 15. I mean, I can do 135 minus 120, that's 15. There's all sorts of ones I can put in there, right? Let's do 60 minus 45. I don't know, let's just do that one. So this is tangent of 60 minus 45. That'll give us 15. So now I need a tangent, and it's a subtraction problem. So the tangent difference formula is right here. Tangent of A minus B is tangent A minus tangent B over 1 plus tangent A tangent B. So when I take a look here, my A is 60, so that's going to go here and here. My B is 45, so that's got to go here and here. So if I have tangent of 60 minus 45, that's going to be, start it over here, so tangent of A, that's 60, minus tangent of B, that's 45, over 1 plus tangent of A, that's 60 again. Tangent B, 45. So plugging the numbers in isn't that bad. Like I said, the only difference is here, now I have fractions. I got a fraction and I have to simplify that, and that makes it a little more difficult to simplify, that's all. So tangent of 60 degrees, when you look on your chart, what do you find? Yeah, there's 60 degrees. There's square root of 3 for tangent. So that equals square root of 3 minus, what's tangent of 45? 45 is there, we get 1 over 1 plus tangent of 60, we already said was square root of 3, times tangent of 45, which we said was 1. Square root of 3 times 1 is just square root of 3. So square root of 3 minus 1 over 1 plus square root of 3. Now, can we leave it like that? Mathematically, that is correct. But can we leave it like that? Nope. Because it's got a square root in the denominator, and that's not proper math, so we should probably simplify that a little bit. Now, like we did on, where did I put that? Oh, it was somewhere else, I think. We must have erased it. What we did before, if I just have like square root of 5 on the bottom, I could times the top and the bottom by square root of 5 and I'm done, right? But because of that plus sign here, we can't do that. Because timesing by square root of 3, I'd have to distribute that through, and then I'm still going to end up with square root of 3 on the bottom. So that's not going to help me. So what we do when we have this 1 plus or 1 minus or something like that on the bottom is we multiply the top and the bottom by what we call its conjugate. Is that a term you've remembered? A conjugate. So you look at the bottom here. The conjugate of 1 plus square root of 3 is 1 minus square root of 3. And if I multiply the bottom by that, I have to multiply the top by that. So whatever the same, it's the same as the bottom, only you flip it from plus to minus. Now what does that do? Essentially, what you're doing is, I think to our factoring and distributed property, we're looking for the difference of two squares here. Like x plus 5, x minus 5. That's the difference of two squares because you end up with x squared minus 25. The middle term goes away. That's what we need in order to get rid of that square root. It's for that middle term to go away. Okay? So now it's just distributed property. So I start right here, okay, on the top. Square root of 3 times 1 is equal to square root of 3. Square root of 3 times a minus square root of 3. Well, square root of 3 times square root of 3 is 3, and then it's positive times negative, so it's negative 3. Then I go to this one. Negative 1 times 1. Minus 1. And then negative 1 times the negative square root of 3. Well, negative times the negative is a positive. And 1 times square root of 3 is 3. Over. Do the same thing on the bottom. 1 times 1 is 1. 1 times the minus square root of 3 is minus square root of 3. And I go to this one. Positive square root of 3 times positive 1 is positive square root of 3. Positive square root of 3 times negative square root of 3. Well, positive times a negative is a negative. Square root of 3 times square root of 3 is 3. And then we simplify. If I look up top here, I have 1 square root of 3 here, and I have another square root of 3 here. So that'd be 2 square root of 3, wouldn't it? And negative 3 and negative 1 is minus 4. Over. And on the bottom, this is why we did that. Positive square root of 3, negative square root of 3, those add up to 0. So then I have 1 minus 3, which is negative 2. And one last step. I can divide that negative 2 out of both of those, can't I? Positive 2 divided by negative 2 is negative 1. Negative 4 divided by negative 2 is positive 2. So you end up with negative 3 plus square root of 2. Tangent. Tangent takes some time. There's only a couple tangent questions on there that you got to worry about. So. One more thing in terms of using these sum and difference identities. We just spent how many days verifying identities, right? We can use these to do the same thing, okay? But to be honest with you, I think these are easier to verify. Let's say we want to verify that the sine of 90 minus theta is equal to cosine theta. Is an identity. So remember, we start with one side, get it to look like the other side. So if I do sine of 90 minus theta, that is a difference formula for sine, isn't it? And I have a difference formula for sine over here that I can look up. And it says sine of A minus B is sine of A cosine B minus cosine A sine B. Your A is 90 degrees, your B is theta. So anywhere you see A, you put 90 in. Anywhere you see B, you put theta in. So sine of A would be sine of 90. Cosine B would be cosine theta. Minus. Cosine of A would be cosine 90. Sine of B would be sine theta. Well, some of these we can look up. Look on your unit circle. What's the sine of 90? 1. Cosine theta I can't do anything with. Minus. What's the cosine of 90? 0. Times sine theta. Well, 0 times anything is 0. So what happens to that? Gone, and 1 times cosine theta is just cosine theta. And you're done. That's what you're supposed to get. Okay? Problems are up there, they're 1 through 26.